Welcome back to Masters and Makers. I am very happy to be joined today by Stavros Danos, founder and CEO of Aries Cerat. Stavros, good evening there.
Hello, Ron. Good morning. How are you?
Good. Let's start talking about the Aries Cerat organization. Who do you have working with you there? How many people are at Aries Cerat?
So I'm the owner, manager, and designer of the company, and we're currently looking for the seventh. So we're recruiting right now. So we can say that we're 6 individuals, highly trained, and we're looking for the next to be added.
And what do those people help you with? Do they help you with designing or production, assembly? What are their roles?
So the complete procedure from design to from acoustics to electronics, chassis design, everything is done by myself. So the people in the company are trained artisans first and technicians second. So they help me with the construction from the speaker finishing, woodworking, electronics, metalworking. So we pretty much have, at the same time, we are specialized. Each individual has its own specialty, but everybody helps with almost everything. So we might have let's say, the people which are specialized in sanding and polishing, but at the same time, they can help with the metalworking. So we're happy to have a team of very highly skilled, talented people that help with pretty much whatever they need to in the process of manufacturing. For the design, everything is done by me, so I carry the weight.
So you write the schematic diagrams.
Yes, everything from speakers to electronics.
And so that team does all of the electronics assembly and soldering and speaker assembly. So it's all in-house.
Exactly. Everything is done by house. I do a lot of manufacturing as well. At least some, let's say, parts of the procedure that they are not, let's say, our people are not there yet to do it. So I help with very specific parts of the assembly, which are very specialized. So let's say the end part of the assembly, testing, first startup, this is done by me as well. And I do also the final auditioning and, let's say, the clear to go for each individual, equipment we send out.
I know that you have 5 different lines of components: prestige, reference, signature, limited edition, and legend. And I counted 29 components on the website. So what is the thinking behind having so many lines and so many components? Is that potentially confusing for clients?
It can be confusing if you're not, they do carry behind them a certain thought process, how they are lined up, but it's not intuitive in a way that it's not easy to do. We try to do a presentation in our website, which is under construction, to, let's say, have a structure to help people get an understanding of the lineup. But the series of components on themselves, for example, the sources, the digital sources, the main lineup is the Cassandra, which itself has its own structure. It goes reference, signature, limited edition, and then we have the Legend series. So it's not intuitive to see on the first from the first side, but it does carry some meaning behind it. Same thing with the Talos, and we do have each of the series is a showcase of a specific technology we use. For example, the Impera series, it's a showcase of our inverted triad technology. So in the lineup, we have the structure of reference, signature, limited edition. And so in a way, you can say that each component has its place because it uses different technology, it's different series. We try a lot not to just fill the lineup. I try to keep minimum, or let's say soft obsolete, some some of the designs, not hard, let's say, stopping something, but it's a natural evolution of the thing. For example, now with the launch of the Janos series, which it has, again, its own structure with the low level and high level equipment. Now it has its own source internal of the series, of the Janos series. So in a way, you can see like its own ecosystem. Each series has its own ecosystem. Same with the Legend series. It's like a self-contained series. It has sources, digital, analog sources, preamp, and amplifier. So in a way, each series has its own structure, internal structure.
I'm going to ask you some questions about why you think certain circuit topologies and designs sound better than others. But to do that, I'd like to get an understanding of what is good sound to you. What are you trying to achieve sonically with your components and with your whole systems? How would you describe the sound you're hoping to achieve, or what is your sonic or audio musical objective with your components and systems?
So my objective is going back why I started, doing this, is what you go and hear, in quote, top level systems, but these do not give you the sense that you have a live instrument unamplified in the room with you. If you have a saxophone in a closed space, it will just, fill you with adrenaline, blow your ears out. But you don't feel this with almost all systems, dependent of price. So what I try to do is I try to give a music reproduction that will give you this sensation of live music, these dynamics and this fullness, density, not in a way that we try to follow what is audiophile, politically correct, treble and mid bass and bass. What I always ask myself, does that thing sound like, is it trumpet at 5 meters away? Doesn't sound like it. If it doesn't, then I don't care about, solid state or tube or whatever. You try to go to the route that will give you that sensation of a live instrument, in the room, which is not it sounds like cliche, but that's the optimum goal. So there are many ways to, let's say, skin a cat, but most of the ways are not, let's say, doesn't lead to the same path. So what I try to do is just think outside of the box. How do I achieve this? And the rest follows up.
It doesn't sound like a cliche to me. Other designers have distinctly different philosophy, so I totally understand what you're saying. I understand that you have a whole system design philosophy of putting a large amount of gain into the source, a moderate amount of gain into the line stage, and a relatively small amount of gain into the amplifier. What is the thinking behind this design philosophy?
So in general speaking, low gain systems, and for example, low gain amplifier, low gain preamp, will sound usually better. Now, this is a dogma, and I really hate dogmas, but there is a reason behind it. So let's say you have a two-stage amplifier or single-stage amplifier, it will sound better than a four-stage amplifier, all things being equal. So what we try to do is we distribute the gain. It's not much that, okay, we try to give low gain amplifier and high level source. We try to distribute the gain. So usually the case is not how it goes in audio. Usually they have a low level signal in phono stage or let's say the digital source, and then you have to compensate on the amplifier. They have very high gain amplifiers, multiple stage, especially in solid state, which we don't really like that. We try to distribute the gain. And what is very an objective way to look things is that if you have a very high gain, very high voltage output DAC, and if you keep all things equal, you just gain very low noise in the system as free lunch. And why this is the case? Let's say you have, I'm going to go to extreme cases so you get familiar with it. Let's say you have a DAC which is 0.5 volts output, and then you have the DAC which is 20 times higher. voltage output. So independently, you're going to have 20 times lower noise in your system automatically, because you don't have to amplify that signal 20 times more to get the same power output at your speaker. And if all things being equal, you're still going to have noise pickup from your cables, from your grounds. You're not going to get away with that. Even let's say if you have a DAC which is 130 dB, SNR, you're still going to have noise pickup from your cables, from your common grounds. You're not going to avoid that. So if you have a DAC which is 20 times higher voltage output, then you have a free lunch of 20 times less gain overall at your speaker terminals, because you have less total amplification in your system. You have 20 times less amplification in your system. And if you do the same procedure for the whole series, for example, in your analog as well, then you have, let's say, the, in quotes, free lunch, lower noise in your system.
I know you like the sound of low impedance topologies. Why do you think low impedance circuits sound better?
Well, if you go measure-wise, they do have more bandwidth. They have much higher bandwidth, and they do have much lower. They're less prone to noise pickup. They're more immune to noise pickup. So this is the technical aspects. Now, if you go more deeply, you're going to say, okay, let's say if you have with the same components, if you have lower output impedance stages, then you are less prone to bandwidth limitations and phase distortions from your passive components. So let's say you have, let's go macro, let's do it in macro stage and not micro stage. Let's say if you have a DAC, which is 1,000 ohm output impedance, and then say you have a DAC, which is 10 ohm output impedance, then in theory, the cable parasitic properties of resistance and capacitance and inductance will have 100 times less impact on your bandwidth with the low impedance DAC. Everything stays the same, just change the impedance. So the effect of the cable is 100 times less. So this is one way to look at it. Empirically, they do sound better because there are other parameters in play, lower impedance tubes, they're more linear, they're more, you can use different topologies. So it's a multiple aspect way to look at things. It's not just lower impedance versus higher impedance. There are some technical advantages to do that in terms of, as I said, less immune to noise pickup, more bandwidth, but also comes from the circuits used and tubes used. So there are a number of ways, facets to look at these advantages.
I know the inverted triode circuit gives you extremely wide bandwidth, but in the audio frequency range, is the bandwidth of conventional small signal triode amplification really a problem to start with?
The advantages of the inverted triode are not just because of the higher bandwidth. So you can get very higher, bandwidth using the same component. So for example, if you have the same output transformer, being used with a very low output impedance tube, like a 300B, which is a very low plate resistance tube, and the inverted triode, you can have, let's say, 10, 20 times more bandwidth just because of the much lower RPE of the internal resistance of the inverted triode. But what we find very exciting about the inverted triode is that it's more than the sum of, let's say, its technical advantages in terms of the output impedance. It doesn't tell the whole story because let's say you have a transistor output, it's going to have less output resistance, but it will not sound the same. Let's say the magic in quote of the inverted triode is the way that the electrons are being controlled. The dynamics and the kinetic energies of the electrons are very, very different in the inverted triode. And that's where I find the differences It's not just to measure the bandwidth or the the linearity of the tube, which
And
they have
how
very
does
high advantage.
how does that translate into sonic advantages? What are the sonic improvements and benefits of the inverted triode circuit that you hear?
Well, I'm going to use the words that anybody who hears it says how it's described. It's like the opposite of a tube compressor. You know how a tube compressor works in studios. It just compresses the peaks. The inverted triode feels that it just expands the dynamic range. It doesn't sound louder, but it sounds much more uncompressed. So that's the sonic, let's say, description of the inverted triode, which is it's repeated. It's in every component we use, because we use it in our top level sources like the Homerus DAC and the Zephyrus phonostage. They use inverted triode. So the sonic advantage is very, very audible of the inverted triode. What it does to the sound, it's I think the opposite of a compressor is very, very to the point. Some audiophiles clients pinpoint this description, and it's very accurate. It's like an expand, it's like an accordion, if you think of it.
You think that single-ended inputs and cables sound better than balanced inputs and connections. Why is that? Why do you think single-ended circuits sound better?
Well, I don't think that. It's not as I described, as I told you before, I don't like dogmas. I hate dogmas in everything in life, not just in audio.
Well, I know that DACs use a balanced topology.
Exactly.
And I know that the input of the phonostage is balanced.
Exactly. So in my opinion, we're not like dogma is no single entity is the best, push-pull is the best, solid state is okay. We don't do that. I always try to say, what's the goal? How can I achieve this? What's the best route? And we start by blank. If we found that, let's say, balanced application on this specific, stage and specific equipment to do a specific job is better, we're going to use it. And case in point is the Cassandra, for example. The Cassandra banks, the converter banks, are differential. So why we do that is because the worst linearity in R2R DACs and in Delta Sigma DACs is near the zero level. So this is where the worst linearity is in the DACs, in the converter, especially the R2R DACs. So if you do a differential, you will cancel the non-linearities near the 0 point, which is the maximum, let's say, non-linear region of a converter. So there is an advantage to do that, to do differential digital to analog conversion. Same thing with the phonostage, for example. The cartridge itself, the generator, is balanced in nature. So the coil inside is balanced in nature. It has advantages if you amplify it in balance, because you'll cancel the common mode noise picked up, and especially in phonostages where we're talking about millions of a volt at best. So it makes a lot of sense to cancel the common mode noise using a differential input stage, which we do in the phonostage. It really, really lowers the noise level of the phonostage. In line sources, in line level sources, there is no advantage to do that. And with the case is that it's much not simpler, but let's say you can design much better sounding single-ended circuits than balance. So if you don't have the inherent advantage to treat a signal in balance, then don't do it. And there is a number of advantages in amplification, for example, especially in tube with the output transformer. There is some technical reasons why a single-ended transformer will sound better around 0 volt, let's say in microwatt region, than a push-pull. There are some reasons behind it. So in my opinion is that you're going to use the best topology for the application. It's not one size fits all. It's not let's do everything balanced because balance is king, or single-ended is king. We do the best possible for each of the stage. Yeah.
And do you feel that the single-ended circuits sound better because they're simpler, or is there something in the nature of balanced connections and balanced cables that tends to suppress even order harmonic distortion? What is the reason you think the single-ended circuits sound better?
No, you can make a push-pull, have second harmonics and second order harmonics being dominant. So if you take a push-pull and make it, second harmonic dominant to, let's say, simulate single-ended, it will not sound single-ended. So you throw that hypothesis out of the window. What I find, there are a number of ways, let's say, in an amplifier, on the output stage of the amplifier, especially a tube amplifier, the transformer itself is the reason why the single-ended will sound better, is because in a pH curve, it's going to be in much more linear region. So especially in the microvolt region, the microwatt, it's going to sound much cleaner and much direct, let's say. So that's why the single-ended amplifier sounds much better with horns, because with horns you only hear about some milliwatts. That's why the difference is very, very big between push-pull and single-ended with horns, because this is where the region that single-ended excels. If you're going to put single-ended versus push-pull in a big panel with 79, dB per watt, you're gonna lose the advantage, and then you're going to go to the region of the advantage of the push-pull, which is higher power. So you have to see everything in a holistic way. It's not one size fits all. It's not, okay, everything is better in single-ended, or vice versa, everything is better in balance. There is a way to do, pretty much, and let's say, suit the design to better suit the application, than going the other way and say, let's make the best single-ended. No, it doesn't work like this. We go the other way around, how we do the best output for this, or the best driver, or the best input.
Well, I very much appreciate the non-dogmatic approach.
I think it's the only way to open up ways to innovation. What we always do is we just throw the book away, prior art. I never design having in mind prior art to anything. I just say, okay, that's a problem. How do I treat it? And then we go and see what's done before.
Why do you use step-up transformers in your phono stages? Why not generate all of the gain with tubes?
The tube stage of our phono is probably the highest in the industry. So the Talos signature is about 65 dB with tubes on its own. So with tubes alone, probably the highest gain in the industry.
Well, actually, the Aesthetics IO, I think, generates 86 dB with all tube gain.
Right. That's fantastic. So usually it's about 50 dB plus the step-up transformer. That's the norm, or about 45 to 55. So we start with 65 just with tubes, and then we add the step-up transformer, and then you go to upper 80s kind of gain, which is, we always prefer to have a headroom than miss some gain and trying to find it from other ways. I always like to have very high headroom in voltage output in the source than trying to compensate in other stages later on. Now, what I find very interesting is that some cartridges prefer to be inductively loaded. That is, it doesn't have to be a transformer, step-up transformer. Even with a choke, they really like to be inductively loaded. And this is one of the advantages that we don't discuss a lot, but many of our phonos, especially the top level ones, have inductive loading without being, without using the step-up transformer. And what we find is that many cartridges really like this inductive loading instead of resisting loading or no loading at all. This is why I believe why many cartridges do like to be loaded and sound better with step-up loading, even if you don't need the gain. So, for example, I advise many of our clients, even if you don't need the gain, try the step-up. And in many cases, the cartridge does sound better, especially if the step-up is designed around the impedance of the cartridge, because fortunately, not all cartridges, are low impedance. But low impedance cartridges really take advantage of the step-up in terms of sonics, not just the gain.
For your Exa-Core amplifier, why do you prefer the sound of the 813 tube over the sound of the 845 tube?
813 is probably my favorite big bottle tube. It's highly linear, very open tube, very transparent tube. We now kept it for our top models alone. So we use the 845 to the low to medium level tube amplifiers. For example, we replaced the 813 in the Genus and the Concero series up to the reference point. And then we keep the 813 tube for our bigger models. If you see spec-wise, 813 has some advantages. It's not crazy superior in sonics in the spec sheet, but it does sound much better than its specs would suggest. There are reasons why. One of the reasons is usually tubes with much higher temperature and much higher current in their filaments sound better. Big tubes with very high current filaments, thorium tungsten, which is now probably forbidden because it's materials that are not they're not allowed to be used now. They do sound much better, and I think it's a matter of materials which, for many reasons now, they're not allowed to be used in tube construction.
When you say sound much better, let's talk about specifically. Do you feel the 813, I don't want to mean to put words in your mouth, but do you mean does it have greater transparency, greater tonal density? What are the sonic attributes that you think you're achieving with the 813 that sound, in a practical sense, better than the 845?
Well, one way to look at it is that you can make, there is, let's say, an aspect in designs that they say that you can make any tube sound in any way you can. You can make an 845 sound lean or lush or just horrible. There are a number of ways to treat a tube. I find the 813 has, let's say, a higher ceiling of performance than 845. Of the modern ones, the only tube which I find it can be at that level is the 284, which is the molybdenum version of the 845. It's an incredible tube. I think it's the only tube that can match the 813 in terms of what's the highest ceiling you can go with. But I think it's wrong to attribute some sonics to a tube. Let's say 300B is lush or not good, or that you can make the 300B sounds like a bad solid state, and you can make a 300B sounds like a lush, romantic vintage tube. There are many ways to design something, but the maximum ceiling of performance of a tube, that's where, if you put everything to it, how good will it behave. And I find that 813 is much higher level than the 845. It doesn't mean that any tube with that tube with a 13 is going to be better than any amplifier with 845 tube we design. There is a number of ways to design amplifier, driver stage, passive components, output transformer, of course, power supplies. What I find different is, the maximum, performance ceiling, and I find the 813 to be higher. That's why we use it in our higher models.
Have you ever thought about using a giant bottle like a GM100 or an iMac tube in a single-ended configuration to generate 100 or 120 watts?
Now we're trying to move away from big bottle tubes, even the 813 altogether, with the Janus range and the Triad FET. But the problem with having tubes like AMAC and this, you have very little availability. I really don't feel comfortable offering an amplifier which you're going to chase, stock to have, to have as replacements. For example, there are very nice tubes out there, some AMAC tubes. The thing is, how many can you find, firstly? And second, they're not, some of them are impressive to look at, but not as impressive in sound. Many of them have, they are very, very non-linear. They are very, very, there are different applications. They are designed to work as pulse amplifiers, for example. So they have much less linear ratio than the 845 or the 813 or 300B. They do look incredible and impressive, but they do not sound the same. I think the 813 is the sweet spot between size and sound. Usually smaller ones sounds better than the big ones. So I think the 813 is the higher you can go in size and keep this small tube, purity. I think the higher you go after 813, you just lose the sound thicker. You can't have the finesse of the smaller tube. So I think that's the limit of how big you can go.
What about an amplifier, parallel SET amplifier, which parallels, say, 4 813 tubes? Have you ever considered something like that?
Yeah, of course. We made some prototypes. The problem is complexity and if somebody's willing to have something, as like a huge heater in their living room. But of course, we made prototypes with them. The sky is the limit with that tube. You can make 1,000-watt amplifier with the 813. It's just a matter of size, cost, and how many air conditions you have in cooling your room down. But it is possible, of course.
Is the triode FET device made out of silicon like a transistor?
So the triode FET is, if you look at it as a black box, it's a virtual component. So it's comprised by silicon and tubes. If you look at it as a black box, so if you take a black box with 3 terminals and you measure it, it's going to measure like a tube. So if you put it in a, let's say, tube curve tracer, okay, or transistor curve tracer, and you trace it, it's indistinguishable from a triode. The only difference is that its scale is going to be in volts, same thing as a tube, but its current scale is not going to be in milliamps, it's going to be in amps. So that's the only differentiator from a tube.
But are you describing the triode FET as a combination circuit, or is it a singular silicon device?
No, it's not a singular device.
Okay.
It's a circuit which, if you take it as a 3-terminal box, which is actually a 3-terminal box, so it has a plate, a cathode, and a grid. Now, if you take this circuit and you see it as something, again, like a black box, and you trace it, it's exactly like a triode, but it can surge and source amps, not milliamps. So if you take this and treat it like a complete active element, so you have your transistor, which you design your transistor circuits, and then you have a tube, for example, which you can design your tube circuits. You cannot use a tube in a transistor circuit and vice versa. Now, if you have an active stage like a triode FET, it opens possibilities in different circuits which you could never design before, because there was not such active element in existence before. There was not an active stage which had the linearity of a triode, so it would behave like a triode, but it worked in amps, not in milliamps. So it really frees up a lot of possibilities in circuits that were never possible before. For example,
in the quintessence, I understand that that's a single stage because the tubes are in parallel with the output stage. So is it collectively the tubes in parallel with the output stage that you're describing as the triode FET?
No, it's not what people confuse the triode FET with the hybrid. The hybrid is it's either a tube which drives a solid state or a solid state which drives a tube. That's a hybrid.
Right. And I understand the
triode
quintessence.
FET,
I understand the
yes,
quintessence is not that because it's a single stage circuit because the tubes are actually in parallel with the output stage.
exactly. It's the tube is copied, so the curves of the tube are magnified, and the tube is actually driving the output. So it is, if you see it electrically, it's not the tube driving the solid state or the solid state the tube. The tube is actually driving the output. The output is the tube, but it's just magnified. It's like on booster, and that's why you don't get the solid state. The problem with the hybrid is that you have a tube stage and a solid state stage. Okay, each one of the stages has its own distortion spectrum. Okay, its own distortion distribution, which will be superimposed. Okay, you're going to have both the tube distortions, and you cannot avoid the solid state distortions. With the triode FET, the tube, the curve transfers are the same as a triode. So you cannot have distortion spectra of a transistor because you're going to have distortion spectra being sourced from a triode. So if you take the triode FET and put it in a bench and measure it with the distortion analyzer, you're going to swear that that's a triode that you're measuring because you are actually measuring a triode. You're just, let's say the triode FET uses a tube which copies its curves. And with the quintessence and ascendia, it uses two tubes. You can use single or two tubes, and it will combine the curves to a third kind of curves, and that will be amplified. So in a way, is that you're creating a new breed of tube. You are mixing matching. Let's say you have E280F with a certain type of curves, and then you mix it with the 282, which has completely different curves, and you superimpose them, you create a third type of curves, and then you amplify it. So it's the holy grail of tube rolling because you're actually making new breeds of tubes, and the possibilities are endless. You can mix and match 9 types of tubes. You can get crazy combinations out of it. And if you measure it to finish up, if you measure this stage, and then you measure the 285, let's say, in a tracer, you're gonna see that it has the same spectra, distortion spectra as the tube, because that's the tube which created the curves, and the curves are being used to the output stage. That's why it does sound like a tube, but it doesn't sound like it. It sounds much more than a tube, than the tube itself, which sounds counterintuitive. But there is a reason why that is. Let's say it's a bit technical, but let's say you have a 280 tube with an output transformer. Okay, the output impedance of the plate impedance of the tube itself will determine much of the distortion spectra and the bandwidth in combination to the passive components, parasitic, capacitance and inductance. So you're going to have lower bandwidth, let's say, because of the output transformer parasitic properties. If you use the same tube to make a triode FET, and then use that triode FET to drive the same output transformer, okay, it's going to sound more 82 than the 82 itself. Why? Because it's going to have much lower output impedance. So the effect of the output transformer would be many times less. So the crazy thing with the triode FET is that you're actually hearing more of the tube than the tube will sound on its own, which is very, very strange to get your head around it.
Yes.
But this is what is happening. This is what is happening with the triode.
What do you mean that the tube sounds more like itself than by itself? I'm just not really understanding that.
So let's say you have it's a bit tricky to get your head around it, because when you have a tube stage, you have to remind yourself that you're not listening to the tube only.
Oh, you're saying that
listening
the
to
transformer is adulterating the sound of the tube less.
Exactly. So
Okay.
you can never hear the tube on its own.
I got
Let's say you
Okay.
have a yes.
Okay.
So you just hear more of what the tube does than what the tube will do on its own, because the impact of the components have much less,
Understood.
let's say, saying to the final outcome.
If a customer comes to you and says, I'm looking for an amplifier in the 60, 65 watt range, how do you help him or her choose between the quintessence and the hexacore? Similar power levels, what do you hear as the difference in sound between those two amplifiers?
So first, I would have to know his background, what his preferences are, because it's a hobby that it's preference driven. Whatever we might say, it's preference driven. So if I see that in the past he chose amplifiers which are not as neutral, very syrupy, slow, sluggish, which objectively will be less ideal than his other amplifiers that he tried, then I will know more or less what he's up to. I have to know his speakers, I have to know his sources, so I get a feeling of what his preferences are, and then I will just go by that. In my mind, there are some differences in the hexachores and the quintessence. The good thing with quintessence is that you can make it sound like 100 different ways because of that tube combination type of situation. Subjectively and objectively, it sounds superior.
So what is the sound of the hexacore? How would you describe the sound of the hexacore on itself?
By itself? It sounds like a top-level single-ended amplifier. So you take this single-ended type of sound and you just try to take it to extreme. The triode FET sounds very different. You have to hear it to understand how it sounds. It doesn't sound like a solid state or a tube. It's like a third pillar in sound, and it's very, very different than anything we designed, or I didn't find anything out there that sounds like it, because it doesn't sound like a hybrid or solid state or tube. It's very, very peculiar, not peculiar, but let's say unique, distinguished kind of sound. Yeah, it's very unique sound. So so far it won tube guys, it won solid state guys. So it's very difficult to get solid state guys to go to tube, even if the tube is top level.
Right.
And the other way around, it's very difficult to go from somebody who is just single-ended only to go to solid state. What I found with the Janos range is that we gain a lot of users that were hardcore, either purist 5 watt single-ended, or other way around, huge solid state kind of guys. So yeah.
With respect to speakers, do you care about a measured flat frequency response? Is that something you look at, or do you care only about how the speaker sounds?
Well, that's let's say the flat frequency response is a prerequisite. So you start from there, but there are, in my opinion, 100 different things you can look after that one. How was the frequency, flat frequency range achieved? But in my opinion, the flat frequency response is a prerequisite. You have to have that, but it's not. I would start by saying that a flat frequency response is the best way to cheat. If you have a very lousy speaker, you can make it sound flat, but it would still be a very lousy speaker. But a top speaker has to measure flat. Let's call it like that. So it doesn't mean that if it's flat, you're there, but doesn't, and the other way around, you cannot say you have absolute top level speaker, but it's just, all over the place. I think it's a prerequisite, but after that is a very, very long, painful story how to make a speaker, sound like a top speaker. Between
the Symphonia and the Aurora, How do you feel the Symphonia sounds even better than the Aurora in terms of realism or believability? What does a client achieve going from the Aurora to the next model up, the Symphonia?
Aurora now is trying to replace Symphonia. So
Oh,
Aurora
okay.
came after Symphonia. Yeah. So the Symphonia has a bass horn as bass, which is a compromised bass horn because it's not huge speaker. So the Symphonia, let's say, compromise is the bass horn size. So up to the frequency response, frequency level it can play, it plays magnificent. The problem is after the bass horn unloads. Also, the bass horn is a peculiar, animal. You have to really know how to set it up in a room correctly. Also, you have the problem that bass horns is the opposite of big speakers. A bass horn will play lousy in a small room. It will really need more room to breathe. Whereas if you have a big speaker in, let's say, a smallish room, it will have too much bass. And if you put it in a hall, it will have almost no bass. Bass horn is the opposite. Bass horn needs space to play around. So it's not as flexible as having, let's say, the tunable bass section of the Aurora, which is tunable in a number of ways. So you start with the handicap there. But bass horn, in my opinion, is superior in all, bass reproduction, methods. The problem is, where you start the compromise or not. Compromise of size and adjustability. So we try to do the second best thing. That's why we went up with the peculiar way of bass loading of the Aurora, which is a hybrid type of baffled to a periodic type of loading. So you have some back pressure, but at the same time you don't have the box coloration of let's say a closed box. So that's, in my opinion, the second best way to do bass if you're not up to bass horns.
When you go home to relax and you still want to listen to music, do you put on a record or do you play digital?
At home, I haven't set up anything because if you hear the speakers we have here for 12 hours a day, you can't replicate that at home. So I try not to set up anything at home, although lately I'm having some, bad thoughts to set up a big horn system. But, when you're at the lab here and you listen to the big contenders for 10, 12 hours a day, then, everything else will sound very, very bad at least. So I choose not to listen to anything at home.
And when you're designing the speaker and evaluating the speaker and testing components at the office, at the lab, do you typically use vinyl or do you typically use digital?
Both. Both.
What's going on in the research? Sorry.
Yeah, so go ahead.
What's going on in the research and development department at Aries Cerat? What's the next new product or the next new technology we should expect from you?
So for the last year, we are very, very busy of expanding the Janus range. So a lot of programmed and unprogrammed designs came out this year. For example, Quintessence was programmed to come out because we wanted a higher level of a Sendia. Let's say we wanted to take the Sendia amplifier let's say design and just push it at maximum. So it was kind of programmed way to go. What was not programmed was the source, because we said, okay, the Janus range, needs a source, but it's complicated to use this very complicated triode FET system. Just take it to a DAC, and so it was not, let's say, in the schedule, but we did it as an experiment. It was so good that we said, okay, we just launched it. So that's how the Ithaca was launched. And now we're in the same thought process of, okay, why don't we do it for a phono, for example, or smaller models. So the Janus range has, I think it's a natural way to expand this range. It's a natural evolvement to just try to use this technology to other type of equipment. Mm-hmm. We already expanded the amplifier range a lot. We have 3 monos out of it. We have an integrated. So now the natural evolvement will be uses in sources, not just in the amplifiers. So I think we can say we're pretty busy just with this one. We also had very nice developments in the inverted triode with the generation 3 of the inverted triode, which now it's only used in Agito, which is reserved for the Janus range. So it's a parallel process. We try to push each of our technologies a bit further, but try not to be overwhelmed by it. We try to keep let's say natural evolvement of things, not to push designs out, but fill in the blanks which naturally occur within the range.
Stavros, this has been wonderful. Thank you so much for taking the time to talk with me tonight for you.
It's been a pleasure.
Thank you very much.